Welcome, Form 4, Physics, Topic 6, Optics, Notes, Lesson 16. You must have watched the previous lesson 15. We continue on refractive index, the formulas. Now I'm going to explain the last formula. Okay, now for this, I prepared a medium. This box is a medium, and it is a medium of high density. Okay, it is high density, and then out of this medium, out of the medium 1, I've prepared medium 2 of low density. And then I have an object on the bottom of medium 1, and the surface of the medium 1 is the boundary. The surface of the medium 1 is the boundary, and I draw a light ray from the object to the boundary. So this would be the incident ray. And then I draw the normal line which is perpendicular to the boundary. Now to find out what is the refraction, we go back to our previous notes, which I did these notes, that the speed of light ray is inverse to the density of medium, and also the speed of light ray is proportional to R, angle of refraction. Now in this situation, the light ray is traveling from medium 1 of high density into medium 2 of low density. So light is traveling from medium 1 of high density into medium 2 of low density, which means the density is decreasing. So according to these given nodes, if the density is decreasing, therefore the speed is increasing, because the density and the speed is inverse. So when the density is decreasing, the speed increasing, and the speed is proportional to R, angle of refraction. So when the speed is increasing, the R is increasing. We have the R which is increasing. And we know from previous lesson, when I say R is increasing, the refracted ray is away from the normal line. This was our original direction. The one I'm drawing now is the original direction of the incident ray. So when R is big, the refracted ray is away from the normal line. So if I were to draw on this side, this is towards normal line. On the other side, away from normal line. And this refracted ray that is entering our eyes, the refracted ray that is entering our eyes looks as though coming from a straight line where the image is formed. Okay? Next, the depth of the object, meaning how far. When I say the depth of the object, it means how far is the object from the surface. The depth of the object is how far the object from the surface. And that depth is called the real depth, capital D. And then the next one, the depth of the image. The depth of the image from the surface of the medium, it is called apparent depth, symbol small d. And the formula, the last formula, formula 5 for refractive index of a medium is the real depth capital D, real depth, capital D. This one, this one, real depth, divide by the apparent depth, small d. Now you might be wondering here that the medium is medium 1. And previous lesson I said, if I say refractive index of a medium, it's supposed to be medium 2. It's very simple. You see here, the light ray is traveling from medium 1 to medium 2. I did this so that I can get the image. Now all I have to do to make medium 2 the second medium, I'm going to reverse the light ray. The path of the light ray, I can reverse. I let the light travel from medium 2 into medium 1, go inside. Okay, now how shall I draw this? I'm going to change the path of the ray. Originally, it is from medium 1 to medium 2. Medium 2 is air, usually. I reverse it up. Now I let the light from medium 2 into medium 1. Now I do this. So when I reverse the direction, now this means, now this has become medium 1 and this has become medium 2. Remember previous lesson? When I say a refractive index of a medium, that medium is the medium 2. Okay? Next, final notes on refraction is the effects of refraction. Okay, the effects of refraction, there are many. I list out some of it. Some of the effects of refraction is straight object, it appears bent in a liquid. Straight objects appears bent in a liquid. Next, the base of a pond or a swimming pool appears shallow. And third, the sky appears blue. And finally, soap bubbles or oil bubbles appear colorful. If you notice, in all these effects, I've used the word appears. I see, appears. It looks to our eyes like this because of the effect of refraction. On the next lesson, which is going to be a very critical lesson, I am going to do total internal reflection. Okay, this is what I'm going to do in the next lesson. And this total internal there's an N missing. This total internal reflection is one of the most important part in optics. So I see you on the next lesson to learn about total internal reflection. Thank you.